And it's an R squared relationship. So what else would it depend on?
Velocity. I would say velocity.
The force is not going to depend upon the velocity directly. There's probably an indirect connection you can make, but not the velocity.
Is mass going to be involved?
Not here.
The amount of charge?
Yes. The amount of charge is involved. By Newton's third law, that I should be able to just switch the charges and they have the exact same amount of force. So there are only two basic operations, multiplication and addition, where we commute and get the same answer. Happens to be multiplication here. So Q1, Q2. Big Q's or little q's, whatever is appropriate. And then obviously I left a space up front because, well, depends on what unit system you're working in. And I labeled this two different things here. There's case of E, or sometimes I'll label it case of C. First off, it's a lowercase k. This is if I'm calling it Coulomb's constant. Or also called the electrostatic constant. Sometimes I just lazy and write the K, but I really should have a subscript there. In SI units, it rounds off to that. I'm writing 9E9 just as a way that you'll remember it a little bit better. 8.99 times 10 to the 9th Newton meter squared per Coulomb squared. And you can count, it's irrational, that's the word. It's an irrational number, but you can actually take it out however far you feel like. But there's a somewhat exact number there. But we'll get to that later. I'm also going to introduce another term earlier than I usually do. This is also equal to 1 over 4 pi epsilon sub 0. And epsilon sub 0 right here, this bit is known as the permittivity of free space. What the permittivity is, and we'll go into more detail in chapter 19 for permittivity. What the permittivity is, it's a measure of how a material is affected by an electric field. Or when we get the separation of charges here, how much the charges get separated based upon this charge right here is dependent upon the permittivity. Free space is, in essence, that sort of the smallest value for permittivity. And you can calculate it, given that we know the value of K, we can calculate epsilon sub naught. Epsilon sub naught is just 1 over 4 pi. Okay? Any questions to hear? Because we're about to bring the vectors into it. All right, you're just dying for the vectors. Yes. is this? Okay, yep, said correctly. And what does it represent? What's the hat tell us?
It's a vector, and it has a direction.
More specific, but how would that differ from that? What's the difference between the two?
It's in like an axis or a reference point kind of deal?
What, this one?
Yeah.
Yeah. Simpler way of saying that this is unit vector. Now, for those who did not have me before, I'm assuming you're familiar enough with vectors. Like that nod, I guess. Zachary, you're good with vectors?
Yeah.
Okay. A couple years ago, I had a student who, claimed that they never did vectors in the first semester course. I'm not sure how, but. All right, so the hat is indicating a unit vector, it is there for direction. This is a radial unit vector. Now, unlike with I and J, I hat, J hat, or potentially you use X hat, Y hat, I hat, J hat, you indicate which the direction is. You say I hat's to the right, or up, or down, or whatever direction makes sense. With a radial unit vector, it points away from the center. Direction equals away from center. So if it was going towards the center, how would you indicate it?
Negative?
Yes. So if I have Q, so I have Q1 and Q2, and there's a force between them. The force on Q1, I'm suddenly changing my Q's there. The force on Q1 from Q2, so vector. The force on Q1 from Q2. So the convention is that the first, when you have multiple subscripts here, the first subscript is telling you the recipient of the force, and the second one is the source. That's equal to my constant, Q1, Q2, over the distance between them, we'll label that R squared, R2 hat. So if Q1 and Q2 are the same sign, they're both positive or both negative, this whole thing is positive, which means that the force is in the positive R2 hat direction, which means it's going away from R2. So if they're the same sign, the force on Q1 is away from Q2. If they're opposite signs, then this whole thing is negative, which means that the force is in the direction of the negative R2 hat. In other words, it's pointing towards Q2. So if they're opposite signs, the force on this is towards it. So let's just do a simple plug and chug. I have a charge here of 3 microcoulombs and a charge here of -4 microcoulombs. We'll call this 1 and 2. The force on charge 1 from charge 2, we'll just plug straight into there. We'll just go for the shortcut, 9 times 10 to the 9th times Q1. Micro, what is micro? Don't make some stranger in the hallway answer this. John?
-6.
Yeah, 10 to the -6. -4 e -6. Divided by, oh, I have to give a distance there. Let's make that 5 meters. If someone would be kind enough to crank that out.
42.
That would have been great if I could come up with that. I assume you want to talk to them or talk to me?
I assume you made the email.
Yes, I did.
Yeah, no, just a quick one, because, they've already been.
Okay. Someone tell this, because Mike is desperate to talk to you.
I was worried I wasn't gonna catch you this, like, so I told Mike in early, because it's technically the last day, you know? Because that happened once where I was gonna come up here, and then it was empty.
If I had read the email, I would have done that. Right, anyway, do we have an answer yet?
Is there a class in there after?
I don't think so. That's the,
Okay.
anyone? Your word? VOO.
I'm sorry, I didn't.
Oh, okay, I couldn't tell. Are you looking right now?
Yes.
I see several calculators out.
Did you play the final Jeopardy with you?
It's just the people up.
Do countdown music. That's not countdown.
What's countdown music?
You're not watching the right British game shows.
Oh, I guess not.
Anyone?
I got negative 4.32 times 10 to the negative 3.
Negative 4.32 times 10 to the negative 3?
Yep.
That's what I got.
Nope. Units? Think about what we found.
Newton,
Say it again.
is it Newton, maybe
Sorry, having trouble hearing.
not. I said Newton.
Yes, absolutely. And then the R2 hat, because that tells you the direction it's going. The negative R2 hat means that it's heading towards, the force is towards charge 2. I was gonna do a follow-up, another simple one, but that will wait for some other brilliant time. Or actually, there's a video on it, so. Mike has a few words if you've got the time.
Real quick, I'm Mike from the Learning Center. This will be short because y'all already had, the first half of physics. Some of you already know. Is everybody here familiar with the tutoring services that we have over the Learning Center? Like we have the one-on-one. Yes. Okay. You don't know about the STEM lab? Okay. So there's a STEM lab that's on the second floor. It's perfect for physics because y'all tend to need more than just an hour, especially with his master sets. I know how they are. So feel free to pop in there, and you'll also be getting an email. We're trying a new thing, basically a small group tutoring, where a form will go out asking about availabilities, and I'll be running it for like a 2-hour block, and it'll be going over master set problems with numbers change that I've talked about with him to figure out, which one y'all, that the students usually have the most trouble with. So you can make it. I promise you it'll help. Can't say you'll walk away a physics genius, but you'll walk away knowing more than you did.
Yeah, and I'm starting to compile a list, that should be getting to you today.
Okay, yeah, that's what I was gonna ask about once we were done here. Any questions about that?
I also say Mike had me for 251 and 252, a number of years back.
So I've been through the ringer, yeah.
Yeah. Matter of fact, some of the master set problems might look similar to problems that he had on his own tests.
Yeah.
He was probably suppressed those, I did, memories.
So feel free to drop by. The Learning Center is in Ardmore. If you just come in, there's a big bunch of glass windows, you go in there and they can direct you and we can talk about it. If you're like, hey, what is one-on-one tutoring? How do I do that? Just come in and we'll help you out. All right, well, awesome. Thank you.
Don't forget to do the course entry assignment, and master sets were mentioned. You'll see under chapter 18, there's something called master sets, and we can talk about that in more detail on Wednesday, or third, whatever the next time we meet.